Hi there, so this is going to be our first video looking at exponents. It's just going to be an introduction to exponents video. We're going to be looking at what exponents are, how they're represented, and some special situations. If you're looking at how to multiply or divide exponents, or maybe working with monomials or polynomials, then you're probably going to want to look at one of the other videos that we have out there. So just the basics for now. Alright, so what are exponents? Well, an exponent tells you how many times a certain number is multiplied by itself. And to explain this in a bit more depth, I'm going to look at an analogy. I'm going to connect it to something that you should be familiar with, which is multiplying. And I want to say that multiplying is to addition as exponents are to multiplication. That's usually a mouthful, so I'm going to say it again, and then I'll kind of go over it a little bit. So multiplication is to addition as exponents are to multiplication. Well, what does this mean? Well, multiplying tells us how many times you add a number to itself. We should know that. 3 times 5 would mean 5 plus 5 plus 5. We'd add 5 to itself 3 times. With exponents, we've got a similar idea, except the exponent tells us how many times you multiply a number by itself. So rather than adding a number, the same number over and over again, we're multiplying the same number over and over again. So let's look at an example here. So with multiplication, for instance, we'd have 3 plus 3 plus 3 plus 3 plus 3, and we would say that this would be 3 times 5. We've got 3 5 times, so hence multiplying. With exponents, it'd be very similar. We'd still have 3, except this time we have 3 times 3 times 3 times 3. We still have 5 3's, but since we're multiplying instead of adding them, we call it an exponent, and we write as 3 to the power of 5. So we notice that our 5 goes to the top, and that refers to our power. So we can look at what we have here. We write 3 to the power of 5, and look at it in a little bit more depth. So the number at the bottom here, I've shown it in green, is our base. It's the number that's getting multiplied over and over again. The number at top here that is shown in red, the 5, that's called the exponent, or also called the power of the number. And that basically tells you how many times that the base is multiplied by itself. So let's take a look at a couple more examples here. Here we've got 2 times 2 times 2. Well, I've got number 2. It's multiplied by itself 3 times. So I'd have a base of 2 and a power of 3. And we'd read that 2 to the power of 3. Or in this case, you might say 2 cubed. If we look at our next example down here, I've got 1/2 times 1/2 times 1/2 times 1/2. I've got 1/2 being multiplied by itself 4 times. So it would be 1/2 to the power of 4. And you'll notice that we put the whole 1/2 in brackets here. I'm going to talk a little bit about brackets and the importance of them with exponents in just a couple minutes. So that's something to note. So it worked with whole numbers, it worked with fractions, and exponents we can even see if we're using letters. So in this case, y times y times y times y times y times y. Okay, remember this little circle just means multiplying. Well, I've got 1, 2, 3, 4, 5, 6 y's, and I'm multiplying them by itself 6 times. And so we'd write that as y to the power of 6. Of course, this does not have a numerical value until we would know I have a number value for y. In the meantime, we'll just leave it as y to the power of 6. All right, so a couple minutes ago I talked about the importance of brackets. And we're going to take a minute and look in some depth at how brackets are really important when we're doing exponents. Sometimes it might be something you forget. So if you remember order of operations, brackets, exponents, division, multiplication, addition, and then subtraction, which tells us the order that we have to do our mathematical computations. The brackets, the b, comes before the exponents. And that's important because it means that the brackets can change the meaning completely. So if there's an exponent outside of brackets, it applies to every single piece inside the brackets. It's what's known as a distributive property, and we'll see how it plays out and take a look at a couple examples, because as I said, it can change the meaning quite significantly. So if we take a look at this first example here, we've got -3 to the power of 4. And again, we'll notice that the -3, the whole thing is in brackets. What that means is that this exponent of 4 applies to both the negative and the 3. So what does this mean? All right, well, -3 to the power of 4, we said the base would be -3. And the 4 would tell us how many times we would multiply -3 by itself. So it would equal -3 times -3 times -3 times -3. 4 times -3. And if you were to do that on your calculator or multiply it out, we'd end up with positive 81. Remember, we have a negative times a negative would be a positive, times a negative would be negative, times the negative would be a positive again, so positive. 3 times 3 is 9, 9 times 3 is 27, 27 times 3 is 81. So we end up with positive 81. Now, if we take a look at another thing that might look similar, here we've got negative 3 to the power of 4, but without the brackets. Now, why this is different is because the 4 exponent only applies to the base of 3, not to the negative. So this here means negative, and then I've shown the brackets here just to show that it's only the 3 that gets multiplied over and over again. We'd still have 81, but in this case, the whole thing becomes negative. We end up with negative 81 instead of positive 81. Again, a different meaning altogether. And so when a negative sign is inside the brackets, the exponent applies to the negative sign as well. Now, what that means is that if you've got a even exponent and there's a negative sign in the brackets, you'll end up with a positive value. And if you have an odd exponent, you end up with a negative value of your number. It seems a little bit bizarre, but as you practice some examples, you'll see how that's the case. So if the negative sign, however, is outside the brackets, like it is over here, then the exponent, the exponent only applies to the number and not to the sign, and that means your answer will always be negative. So this ends up being negative 81, because essentially what this is saying is, well, take this number 3, put it to the power of 4, and then at the end, change the sign and make it negative. All right, we're going to keep looking at brackets, the more importance of brackets. I know it's just as exciting as it sounds, but let's take a look at another example here. So in this case, I've got a times b in brackets, and it's all to the power of 4, the exponent of 4. I wrote it as a times b. You could also just write it as ab. You don't necessarily need the time symbol. So what does this mean? Well, again, because this is in brackets, the exponent of 4 applies to both. So I've got a times b times a times b, that'd be to the power of 2, times a times b again, that'd be the power of 3, times a times b. So that's to the power of 4. And I'm actually just going to combine my letters here. So what do I got? I've got a times a times a times a, 1, 2, 3, 4 a's, and then 1, 2, 3, 4 b's. So just rearrange them there, and now it should be easy to see that what do we have? Well, we've got a to the power of 4 times b to the power of 4. Here are 4 a's being multiplied, say to the power of 4. Here are 4 b's being multiplied, b to the power of 4. So again, when we have our brackets, when the values inside brackets are multiplied, as they are here, the exponent is applied to all the values inside the brackets. And so it applies to the a and the b. So we can just add them on. So it becomes a to the power of 4 times b to the power of 4. Let's look at another example here where we've got similar, only we're looking at a fraction. So what do we got? Again, brackets around the a divided by b, all to the power of 4 again. So that means a divided by b times a divided by b times a divided by b 4 times, so on and so forth. And what does that give us? Well, same idea here. This 4 is applied to the numerator in the top, so we have a to the power of 4, also applied to the b in the denominator at the bottom. And so when the values inside brackets are divided, like we've got here, the exponent is applied to the values in the numerator and the values in the denominator. Same idea as up top. It got applied to both the a and the b. And remember, when you're multiplying fractions, you only multiply your tops, or your numerators, and then your denominator. So we'd have a times a times a times a, which would be a to the 4, and then divided by b times b times b times b, which is b to the power of 4. So that's called the distributive property, just the idea that the exponent is applied to all of the pieces in the brackets. And now we're going to look at a few special situations, some things that maybe at first don't seem like they make a whole lot of sense, but they all play out. All right, so if no exponent is written, then the exponent is 1. So for instance here, 5 equals 5 to the power of 1, 0.95 equals 0.95 to the power of 1. Same with 3/4, same with m. We don't normally write in the 1 over and over again because it just gets redundant. We don't usually need it. So, but sometimes you'll have questions that are combining numbers with exponents and numbers kind of not showing the exponent. It's just important to remember that in that case, the exponent is actually 1, even though we usually don't write it. All right, another number. This is going to seem a bit weird. Any number to the power of 0 equals 1. Again, as you do exponents, you'll see that this actually works, although initially it doesn't seem to make may not seem to make a whole lot of sense. So what do we got over here? 5 to the power of 0 equals 1. 0.95 to the power of 0 equals 1. Again, it seems a little bit odd. You could have a fraction to the power of 0, and it's going to equal 1 again. And I can erase it a little bit bigger. M to the power of 0 equals 1. This one really messes people up because I've got a letter to the power of 0, but it gives us a number value of 1. Doesn't matter what your number is. Anytime it's to the power of 0, it's 1. And the number 0 is kind of weird because in different math contexts, the value 0 has different meaning. So in the case of exponents, the 0 is just another way of showing of saying that the value equals 1. And let's take a look at a couple more special situations over here. All right, a negative exponent. Well, I mean, how can I multiply a number by itself a negative number of times? Well, I can't really. But again, same idea as that negatives in different contexts in math mean different things. So a negative exponent means that the value is inverted. All that means is if our number was originally in the numerator at the top, we're going to switch it to the denominator in the bottom. If it was in the denominator of a fraction, we're going to switch it and bring it into the numerator or the top. And then we can just get rid of the negative and it becomes positive. So again, we'll look at a couple examples because that seems a little weird. So 5 to the power of negative 1 just means 1 over 5, or 1 over 5 to the power of a positive 1, which we don't usually add in, as we noted. If we look at something like 8 to the power of negative 2, well, that means 1 over 8 to the power of positive 2, or 1 over 8 squared, which would be 1 over 64. Again, we're taking the 8 here, it's in the top in the numerator. Remember, the denominator on the 8 would be 1, and we don't normally write that in. We're flipping the 1 and the 8 around, and then instead of it being negative 2, it becomes positive 2, but the 2 is on the 8 in the denominator. Here we've got another weird example. At 3 divided by x to the power of negative 3. Well, it means we are going to invert it. Of course, since this negative 3 is only applying to the x, my value 3 is going to stay on the top, and the x is going to go from being divided in the denominator to the top being in the numerator. Again, we don't normally think of it in terms of numerator and denominator, but remember our denominator over here would be 1, even though we don't usually write that in. If we get one more example, looking at letters here, it's going to look a bit bizarre. M to the power of negative a divided by n to the power of negative b. Well, the negative exponent here means I'm going to move my m from the numerator to the denominator in the bottom, and my exponent will go from being negative a to being positive a. My n has a negative exponent. It's going to move from the denominator to the numerator, and I'll take my exponent from being negative b to being positive b. And again, as you practice that, that'll start to come a little bit easier for you. All right, one last one to look at. An exponent with a fraction means to take the root of the number. Again, it means that how can I multiply a number by itself half a time or 1/3 of a time? And again, it's a little bit abstract to think of it that way, but again, mathematically it works. So if we look at, say, 5 to the power of a half, that's just another way of saying the square root of 5. And for instance, if we had 1 over 8, or 1/8 to the power of a third, this actually would mean that we take the cube root, big one here, take the cube root of 1 over 8. So it's just saying, well, what number, when multiplied by itself 3 times, would give me an 1/8? And the answer to that is actually a half, because 1/2 times 1/2 times 1/2 is an 1/8. Again, some of you may be familiar with cube rooting, others maybe not so much. And if we look at it a bit bizarre here, m to the power of 1 over n, again we have a fractional exponent, and that just means we take the nth root of m. Again, you can take any root of a number. You don't see it so much until you maybe get up into a little higher levels of math. So there you have it. We've looked at what exponents are. We've looked at how brackets are important. We always need to pay attention to them because they can change the meaning. And we've looked at a bunch of special situations involving negatives, involving a fraction of, an exponent of 0, and involving exponents that deal with fractions. Hope this helps. Thanks for watching, and you can check out other videos for more on exponents. Bye-bye. You've been watching Mr. E, taking the suck out of success.